Hello everyone, welcome to the third video in the series of bivariate data. Following the last two videos on this topic, we will talk about residual plots. Residual is defined to be the difference between observed and predicted values. Today we will learn about the measures of residuals to have a clearer understanding of what they really are, and then we will explore residual plots and learn to interpret them. Residual is the difference between the observed and the predicted values. In particular, it is the observed value minus the predicted one. In this case, y1 is the observed value, and it's smaller than the predicted value, y hat 1, so the residual is negative. For the second data, the residual would be positive, because the observed value is larger than the predicted one. Then we keep doing this operation for all points to obtain a list of residuals for this set of data. We've talked about the least square regression line in the last video in this playlist, so we know that both the observed and the predicted values yield the same mean. Thus, their sums are equal. Putting these together, we get that the sum of the residuals is equal to the difference between the sums of the observed and the predicted y values, which is 0 since they are the same. Following this conclusion, the mean of residuals would be the sum divided by the amount, which is also 0. On the other hand, the standard deviation is given by this formula here, by the definition of residuals. It gives a measure of the spread of data around the best fit line. In addition to the calculations of the residuals, we can also plot the residuals on a graph. They can be plotted against either the dependent or independent variables. The graphs would convey the same information, and the scale would be the only difference. Here are some examples of the residual plots. When we examine a residual plot, we will notice any patterns in the distributions of the points. When a best fit line is appropriate, the residuals are randomly distributed, just like in the graph on the left. However, if there is a pattern, it indicates that a nonlinear model rather than a line is a better fit for that data set. Besides the patterns, we should also check if the points are balanced between the positive and negative values. In the second graph, most of the points are positive, so the line could have described the data even better if it was translated upwards. Finally, we should always read the scale. If the size of the residuals is very large in comparison to the associated y values, it suggests that the best fit line doesn't describe the data well. This is because the least square regression line is meant to minimize the sum of the least squares of the residuals. So it is only when the line doesn't work well that it results in such large residuals. Let's recap. Today, we continue to talk about bivariate data. We introduced the measures of residuals and learned to interpret residual plots. I hope this video helped you have a better understanding of residuals as well as bivariate data as a whole. See you soon!